video, we show how to solve inequalities involving the modulus or the absolute value function. The modulus function is denoted by this and is defined as x if x is greater than or equal to 0 and minus x if x is negative. That is, if x is a negative number, we have a positive value here. And so this shows the graph of the modulus function. It lies only on the positive y-axis. That is, the modulus function is never negative. Now let's see some useful properties that can be used when solving modulus inequalities. Number one, if the modulus of x is less than a, it implies that the values of x lie between minus a and a. And if the modulus of x is greater than a, it implies that x is less than minus a or x is greater than a. And then the third property states that if the modulus of x is greater than the modulus of a, then x squared is greater than a squared. And property 4 also holds. Now let's see some examples. Solve. The absolute value of 2x minus 1 is less than 5. An absolute value of 2x minus 1 is greater than or equals to 5. So let's see how to do that. The first one, absolute value of 2x minus 1 less than 5. So we apply property 1. It means that 2x minus 1 lie between minus 5 and 5 if we apply property 1. And so we add 1 to each side of the inequality. So we have a minus 5 plus 1, 2x minus 1 plus 1, 5 plus 1. So minus 1 plus minus 5 plus 1 gives us minus 4. This gives us 0. So we have 2x here, and 5 plus 1 is 6. So we divide each side of the inequality by 2. So if we divide by 2, we will have minus 2 here, less than x here, and less than 3 here. And this is the solution of our inequality. That is, the values of x lie between minus 2 and 3. Now, for b, we apply property 2 that says the absolute value of x greater than a implies that x is less than minus a or x is greater than a. And so we apply that to solve b. So 2x, absolute value of 2x minus 1 greater than or equals to 5 implies that 2x minus 1 is less than or equal to minus 5, or 2x minus 1 is greater than or equal to 5. And so we solve this. To do this, we add 1 to both sides. So we have plus 1 here and plus 1 here. So we have minus 1 plus 1, that's 0. So we have 2x here. Minus 5 plus 1 gives us minus 4. And so we divide both sides by 2. We have divided by 2 here, divided by 2. And so we have x less than or equal to minus 2. Or 2x minus 1 is greater than or equal to 5. We add 1 to both sides, plus 1 plus 1. So we have 2x here, 5 plus 1 gives us 6. And we divide both sides by 2. We have x greater than or equal to 3. So the solution to this is x less than or equal to minus 2 or x greater than 3. Example 2. Solve. Modulus of x minus 1 greater than or equal to 2 modulus of x minus 4. To solve this, we apply property 3. Property 3 says if modulus of x is greater than the modulus of a, then x squared is greater than a squared. By property 3, we square both sides of the inequality and we have this. So if we expand the left hand side, we have x squared minus 2x plus 1. And expanding the right hand side, 2 squared is 4. X minus 4 squared gives us x squared minus 8x plus 16. So we have this after opening the bracket. And so we now rearrange our inequality so that the right hand side is 0. So we move all the terms here to the left hand side. So we have x squared minus 4x squared, that gives us minus 3x squared, minus 2x plus 32x gives us plus 30x, and 1 minus 64 gives us minus 63, greater than or equal to 0. Now observe that minus 3 is common to all the terms here, so we can bring out minus 3, and we have minus 3 in this gives us x squared, minus 3 in this gives us minus 10x, minus 3 in this gives us plus 21, greater than or equal to 0. So we can divide both sides of the inequality by minus 3, so that we have x squared minus 10x plus 21 less than or equal to 0. Recall that anytime we divide an inequality by a negative number, the sign of that inequality changes. So we have a quadratic function here. We factorize it, have x here and x here, and so the constant term here is 21. Look for two numbers that when we multiply gives us 21, and the addition gives us minus 10. So the factors of 21 are 1 and 21, 3 and 7. So if we add 3 plus 7 gives us 10. So we can have this. So minus 3 minus 7 gives us minus 10, and the product gives us 21. So we have minus 3 here, minus 7 less than or equal to 0. We now find the critical values, that is where each of these factors equals 0. So we equate them to 0. X minus 3 equals to 0, and x minus 7 equals to 0. So x equals to 3 and x equals to 7. So our critical values are x equals to 3 and x equal to 7. With our critical values, we now sketch the graph of this curve. So we have this 3 here and then 7. So we can sketch, is a quadratic curve. So we sketch the graph of this curve in this manner. We are interested in the region where this curve is less than or equal to 0. That is where it lies on or below the x-axis. This region, we are interested in this region. And so the region that satisfies the part where this curve is less than or equal to 0, that is where this curve is below the x-axis, is 3 less than x less than or equal to 7. So x, the values of x that satisfy this inequality is x between these two values. So the solution to our inequality, this is x in between, lying between and including 3 and 7. We solve modulus of x plus 4 less than modulus of 2x by property 4. We square both sides of the inequality, and so we have, if we square this, we have x squared plus 8x plus 16 less than 4x squared. We now subtract 4x squared from both sides so that we can have 0 on the right hand side. So we have x squared minus 4x squared to give us minus 3x squared plus 8x plus 16 less than 0. And so to make our work easy, we multiply through by minus 1 so that the coefficient of x squared will be positive. So if we multiply by minus 1, we have 3x squared here minus 8x minus 16 greater than 0. Recall that because we multiply by a negative number, our inequality changes sign. We now factorize the quadratic function here. So 3 times the constant term here, 3 times minus 16 gives us minus 48. So we look for the factors of minus 40. We have 1 and 48. We have 2 times 24, and then 4 times 12 all gives us 48. We are looking for the factors that when we add them gives us the middle number minus 8. So if we have minus here, we'll have 4 minus 12, which gives us minus 8, and 4 times minus 12 gives us minus 48. So we can replace the middle term here by this. So we have 3x squared minus 12x plus 4x minus 16 greater than 0. We have 3x in 3x squared, that's x. 3x in this gives us 4 plus 4. 4 in 4x gives us 4. 4 in minus 16 gives us minus 4 greater than 0. So we have, if we factorize, x minus 4 is a common factor. We have x minus 4 here. Then we have 3x plus 4 is greater than 0. We now find the critical values, that is where each of these factors equals 0. So we have x minus 4 equals to 0 and 3x plus 4 equals to 0. So we have x equals to 4 here and x equals to minus 4 over 3. These are our two critical values. So with our critical values now, we can sketch the graph of this curve. We have minus 4 over 3 here, and then we can have 4 here. So we sketch the graph, quadratic graph. We are interested in the region where this curve is greater than 0, that is where it is above the x-axis. Now take note that it is below the x-axis between minus 4 over 3 and 4. This region is below the x-axis, so it is negative here, but it is greater than 0 anywhere in the regions before minus 4 over 3 and after 4. So the values of x where this curve is greater than 0 are x less than minus 4 over 3 or x greater than 4. Hence, the solution to this inequality is x less than minus 4 over 3 or x greater than 4. I hope you enjoyed this video. If you have any question, you can drop them in the comment section. Thank you.